another theory unfolds.
In 1977, 2 probes left Earth. They were small, not sleek or cinematic, not designed to impress. They were built to survive for 5 years. Jupiter, Saturn, some quick science, and then silence. They were meant to fade, but they didn't. They endured, they adapted, they exceeded every expectation we had, and in doing so, they became something no machine had ever become. A messenger, not to us, but to the stars. Today, we're covering a story that spans nearly half a century, one of humanity's greatest scientific achievements. It's the story of the Voyager probes, 2 small spacecraft built with 1970s technology, launched with limited goals and modest expectations, and yet they've become something far greater, pioneers in deep space, carrying our voice farther than anything else we've ever made. Enjoy the video. The images you'll see throughout were captured by the Voyager probes themselves during their journey through the solar system. Voyager 1 and Voyager 2 weren't built to last decades. They were built for precision, not permanence. 5 years, 2 planets, that was it. Launched in the summer of 1977, Voyager 2 first, then Voyager 1. Their mission was to take advantage of a once every 176 years planetary alignment, a rare event that allowed a single spacecraft to slingshot from planet to planet using gravity assists. This grand tour was an opportunity so rare and so valuable that it inspired some of the most creative engineering NASA had ever done. Even then, the expectation was limited. The probes would survive their flybys, collect a few images, a few measurements, and go silent. The design reflected that mindset. The computers on board were barely more capable than a modern calculator. The data storage system used magnetic tape. The signals they sent back would take minutes, eventually hours, to reach Earth. There was no backup, no redundancy beyond what could be squeezed into a 1970s budget. Everything about Voyager was a gamble, and yet, they worked. Voyager 1 would become the fastest human-made object ever launched. Voyager 2 would become the only spacecraft ever to visit Uranus and Neptune. The spacecraft were identical in design, but followed different paths, complementing each other. Together, they expanded the edges of the known solar system. They were never built for endurance, but they became champions of longevity. Jupiter wasn't just a photo op. It was alive, a world of swirling storms, erupting moons, and radiation belts. Voyager revealed Jupiter's complex atmosphere in stunning detail. The Great Red Spot wasn't static. It was a roiling storm, larger than Earth, centuries old, with internal turbulence and high-speed winds. But the biggest surprise was Io. Voyager discovered active volcanoes, real-time eruptions. It was the first time we'd ever seen geological activity beyond Earth, sulfur geysers, flowing lava, a molten world shaped by gravitational stress from its parent planet. Europa was next, smooth, bright, and cracked like ice under tension. The images hinted at an ocean beneath the surface, a place that, even now, is considered one of the most promising places to search for life. Then Saturn, the jewel of the solar system. Voyager's cameras revealed the rings in fine detail. What appeared from Earth as smooth bands were in fact complex structures, made of ice, dust, and rock, some no larger than a grain of sand, others as large as buildings. There were gaps and waves in the rings created by tiny shepherd moons. The whole system was more dynamic than anyone expected. And then Titan, Saturn's largest moon. Voyager discovered a thick, hazy atmosphere of nitrogen and methane, a place with chemistry eerily similar to early Earth. Voyager 2 continued farther than any spacecraft had before, to Uranus, a pale, frozen planet tipped nearly sideways. Voyager found that its magnetic field was wildly tilted and offset from the planet's center, unlike anything seen before. Its moons were equally bizarre, particularly Miranda, which looked like it had been shattered and reassembled. Then Neptune, deep blue, fiercely windy, and more dynamic than expected. Voyager discovered the Great Dark Spot, a colossal storm system, and Triton, a moon orbiting in reverse with active nitrogen geysers spewing into the thin atmosphere. Its retrograde orbit suggested it was a captured object, and its surface, coated in pinkish frost, hinted at a violent past. These were worlds we had never seen up close, and we haven't returned since. Voyager 2 remains the only spacecraft to have visited Uranus and Neptune. Every encounter rewrote textbooks, every flyby gave us a new world. While the science was front and center, Voyager carried something else, something quieter and more philosophical. Attached to the body of each spacecraft was a gold-plated phonograph record, a message in a bottle, the golden record. It was the idea of Carl Sagan and a small team of artists, scientists, and musicians. They were asked, if we could send one message to the universe, not for ourselves, but for any intelligence that might one day find it, what would we say? The result was a 12-inch copper disc coated in gold. It included greetings in 55 human languages, music from across continents and centuries, from Bach to Blind Willie Johnson, natural sounds, thunder, wind, a kiss, a baby crying, 116 images encoded as analog data, showing life on Earth, our DNA, cities, people, landscapes. It also carried a printed message from U.S. President Jimmy Carter. This is a present from a small distant world, a token of our sounds, our science, our images, our music, our thoughts, and our feelings. We are attempting to survive our time, so we may live into yours. Carl Sagan described it as a hopeful gesture, a gift to the cosmos. The odds of it ever being found are infinitesimally small, and that's what makes it beautiful. The golden record isn't really for aliens, it's for us. Voyager's original mission had ended, but the spacecraft kept flying, so NASA extended the goalposts. The Voyager Interstellar mission was born, the new objective, to leave the solar system entirely and keep listening. In 2012, Voyager 1 crossed a boundary called the heliopause, the invisible edge where the sun's solar wind meets the interstellar medium. In 2018, Voyager 2 followed. They became the first human-made objects to enter interstellar space. Out here, the sun's influence fades. No more solar wind, no planetary orbits, just the slow breath of the galaxy. Voyager's instruments began measuring cosmic rays and the density of plasma beyond the heliosphere. They discovered a persistent hum in the interstellar medium, a faint vibration that fills the void. They felt the echoes of solar storms as they arrived, years after their origin. Every bit of data is new, every reading is unprecedented. Voyager 1 is now over 15 billion miles from Earth, Voyager 2 more than 12 billion. They are the farthest human-made objects in existence. Each signal takes over 22 hours to reach us. Each whisper from the void, a relic of yesterday, and we still hear them, sometimes just barely. The final years of Voyager are already underway. Each year, more instruments are turned off to conserve power. The cameras shut down long ago. There is no fuel to adjust their course. By the end of this decade, the last of the scientific instruments will fall silent. But in 2023, a new strategy bought them more time. NASA engineers rerouted backup power on Voyager 2, drawing from an unused voltage regulator to keep all 5 science instruments running longer, likely until at least 2026. Voyager 1 may follow a similar path. They are running on borrowed power, and still they endure. In mid-2023, Voyager 2 briefly lost contact with Earth. Its antenna nudged just 2 degrees off point. A single misalignment left it silent in the dark. But engineers at NASA's Deep Space Network launched an interstellar shout, a blind high-power command beamed from Earth across 20 billion kilometers. It worked. Voyager turned, and the voice of the distant probe returned. In 2024, Voyager 1, the more distant sibling, began sending unreadable data. After months of silence and code analysis, NASA discovered that a memory chip had failed. It was impossible to replace, but the team rewrote the software, reassigning code to undamaged memory locations. Once again, Voyager spoke clearly. It had been saved, with nothing but patience and ingenuity. These weren't just repairs, they were acts of devotion. Voyager continues to measure the plasma and radiation in the interstellar medium. Its instruments still detect the shock waves of solar eruptions that took more than a year to arrive. It listens to the gentle hum of charged particles between the stars. No other spacecraft has ever made these measurements. No other machine has seen what Voyager sees. And yet the power continues to wane. Systems continue to shut down. The light grows fainter. And soon the Voyagers will fall silent. But they will continue to drift quietly, endlessly into the night. They will not be destroyed. There is nothing out there to break them apart. They will pass through the galaxy for tens of thousands of years. Eventually, perhaps, they may pass near another star. And maybe, just maybe, someone or something will find them. And long after Earth has changed beyond recognition, long after every name and every city has faded from memory, Voyager will still be out there, a silent trace of us, still holding a golden disc, still carrying our voices, still whispering, "We were here, we wondered, we reached." And that, not conquest, not power, but wonder, is why Voyager is the noblest journey we've ever made. How do you talk to a machine that's more than 20 billion kilometers away? You whisper, and you hope it hears you. Every word we send to the Voyager probes, every signal we receive in return, travels through the deep space network. The DSN is one of the most remarkable communication systems ever built. 3 complexes, one in California, one in Spain, and one in Australia. Together they form a global triangle, always keeping at least one giant ear pointed toward the sky. The antennas are massive, up to 70 meters wide. That's wider than a football field. They were designed not for speed, but for sensitivity. Because Voyager's signal is faint, a single whisper, weaker than the power of a digital watch battery by the time it reaches Earth. And yet, we hear it. The message takes time to arrive. Over 22 hours each way for Voyager 1. The reason it takes so long is simple physics. Nothing, not even information, can travel faster than light. And Voyager's signal. It is light, not visible light, but a radio wave, part of the electromagnetic spectrum. It travels as oscillating electric and magnetic fields, rippling outward through the vacuum of space. At 300,000 kilometers per second, the fastest speed anything can move. But space is vast, so even at light speed, it still takes over 22 hours to reach us, because it's just that far. And yet, when you think about it, what's more amazing is that it only takes 22 hours. A message from the edge of interstellar space, arriving on Earth the next day. That's not just communication. That's connection across time and across billions of kilometers. So every command, every question has to be right the first time. If something goes wrong, the round-trip delay means we can't react in real time. It's patience, precision, and trust, stretched across light years. Keeping the connection alive is its own engineering challenge. Antennas must be maintained and recalibrated regularly. Weather can interfere, even seismic activity. In 2023, engineers had to time Voyager 2's interstellar shout precisely, using the exact rotation of Earth to align the signal with the craft's narrow antenna beam. And it worked. The DSN doesn't just listen, it listens carefully, picking out Voyager's message from background cosmic noise, like finding a single snowflake in a blizzard. Without the deep space network, Voyager would still be out there, but we wouldn't know it. There would be no data, no voices, no contact, just silence. And so, decade after decade, the DSN has kept a line open, a lifeline, a thread of signal from Earth to two tiny machines, sailing through the stars. Before we go further, here are a few things that sound too strange to be real. Voyager's computers, they have just 68 kilobytes of memory. That's less than the size of a single modern photo. And yet, they've guided a mission for almost 50 years. Each Voyager sends data at 160 bits per second. That's slower than dial-up internet. It would take about 10 hours to download a single MP3 file, but it still gets through. The golden record? It includes greetings in 55 languages and the brainwaves of a woman in love. Voyager runs on plutonium, not solar power. Sunlight is too faint where it's gone, so each spacecraft uses a nuclear battery, still running, still fading, very slowly. And the signal, despite being over 15 billion miles away, NASA still hears from Voyager every single day. These aren't just facts, they're reminders that human engineering can still echo across the dark. Voyager has no shields, no radar, no way to dodge, and it travels in a straight line and hopes. From the moment it launched in 1977, the Voyager team knew the risks, not from aliens, but from dust, tiny particles, no bigger than a grain of sand, traveling tens of thousands of kilometers per hour. At that speed, a single one could punch a hole through metal, and Voyager would never call home again. The most dangerous part? Not interstellar space, but the planetary flybys. When Voyager 1 and 2 flew past Jupiter and Saturn, they came incredibly close to dense fields of dust and debris. At Saturn, Voyager 2 passed just 100,000 kilometers from the rings, close enough to see individual bands and gaps, close enough to be torn apart. To prepare, NASA engineers used Voyager's own antenna dish as a shield. They turned the spacecraft around, not to take pictures, but to protect the instruments. The dish would absorb the hit, if it came. It didn't, but it could have. After the planetary tour, the threat changed. The solar system faded behind, and the risk of collision dropped. In interstellar space, the danger isn't gone, but it's rare. The space between stars isn't empty, but it's close. A few atoms here, a stray dust grain there, enough to whisper, not enough to destroy. Voyager doesn't carry radar. It can't detect debris ahead of time, and even if it could, it can't turn. It can't brake. It just flies. In the decades since launch, there have been no confirmed impacts, no sudden failures, just a silent ship, sailing through the cosmic dark. Not because it's armored, but because space itself is so vast and so quiet that even something this fragile can survive. Voyager wasn't alone. Before it, and after it, came other travelers, each one chasing the same dream. In the early 1970s, before Voyager, there were the pioneers, Pioneer 10 and 11. They were the first spacecraft to pass through the asteroid belt, and the first to visit Jupiter and Saturn. Simple, tough trailblazers. Then came Voyager, more advanced, more ambitious. Voyager went farther, saw more, and sent back sharper images. But it was Pioneer that proved deep space was possible. Without them, Voyager may not have flown. After Voyager came silence for a while. Then, in 2006, New Horizons launched its target, Pluto, a world Voyager never visited. New Horizons flew past in 2015 and continued into the Kuiper Belt, the frozen edge of our solar system, just like Voyager. It carried ashes, data, and hope. Each mission built on the last, each one added to the story. From Mariner to Pioneer, from Voyager to New Horizons. Each was a voice, each was a messenger, but only Voyager went the distance, only Voyager. Kept talking, and only Voyager still whispers. In 1990, just before its cameras were shut off forever, Voyager 1 turned back toward home. It was over 4 billion miles away. At the request of Carl Sagan, the spacecraft captured a final image, a tiny Earth suspended in a sunbeam, a pixel. That image became known as the pale blue dot. From that unimaginable distance, Earth appeared as a mere speck, no borders, no people, just a tiny dot floating in the vastness. Sagan later wrote, "Look again at that dot. That's here, that's home, that's us. Every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam." It was a reminder of how small we are, of how fragile, and of how far we've reached. The pale blue dot isn't just a photograph. It's Voyager's final message before disappearing into the dark. A farewell, and a call to care for the only home we've ever known. If you've made it this far, thank you. The Voyager probes may be alone in the dark, but they carry a part of all of us. As a kid, I remember being struck by just how crazy it was to think that something built by humans could be that far away from us, still out there, still moving. It was one of the first things that really pulled me into space. So the next time you look up at the stars, know that something built by human hands is still out there, drifting through silence, carrying our story, and reminding the universe that we were here.